Hello and welcome back to my channel. In this tutorial I'm going to explain thresholding example with OpenCV in Python. Image thresholding is a technique used in image processing to separate image into two or more parts based on pixel intensity values. When we use grayscale image, the process involves setting a threshold value for pixel intensities and then classifying the pixels as either foreground or background based on their intensity values. This technique is useful for various image processing tasks such as object detection, segmentation, and feature extraction. OpenCV provides several thresholding methods that can be used to convert a grayscale image to a binary image. In this tutorial, I will briefly learn how to use some of the most commonly used OpenCV thresholding methods in Python. This tutorial covers binary thresholding, otsu thresholding, adaptive thresholding, and source code listing. Let's get started. We'll start by loading the required libraries for this tutorial. Here we use OpenCV matplotlib libraries. We need an image file to apply the thresholding technique. The following code shows how to load an image and display it in a plot. The file in this tutorial is originally a color image and it will be converted into the grayscale. Here is how to load the file and convert it into grayscale. We also apply a Gaussian blur to remove some noises and improve the thresholding quality. Binary thresholding is a commonly used technique for image thresholding. Threshold value is manually determined to separate foreground and background regions of an image. OpenCV provides a built-in function called threshold that can be used to perform binary thresholding. Below code shows how to apply binary and binary inverse thresholding and display the output images. Here we apply the thresholding technique for a given image. This is the source, this image file, and this is the threshold value. Here the method separates the either foreground or background, and this is the maximum value we set here is 255, and this is the type of the type of the thresholding. Here we apply threshold binary. In the next one is we apply threshold inverse. Then we visualize the both images in a graph. So here is the output, white and black colors, and this is the inverse of the binary image. The otsu thresholding is a commonly used technique for image thresholding in which an optimal threshold value is automatically determined to separate foreground and background regions of an image. We can use threshold function to perform otsu thresholding. Here is the code how to apply otsu thresholding and the inverse version and display the output. Here we again apply threshold function, and here we add the threshold otsu type in here, and this is the output. Here is otsu flag indicates the function determines the optimal threshold value automatically. The same method applies for inverse version. Adaptive thresholding is a technique used for image thresholding in which a threshold value is determined based on a local neighborhood of each pixel. We can use OpenCV adaptive threshold function to perform adaptive thresholding. Below code shows how to apply adaptive thresholding and its inverse version and display the output images. In this code, we apply the adaptive thresholding. Here is the first we provide the source image, and the next parameter is a max value, the maximum value that can be assigned to a pixel, and the next one is the method, the adaptive method used to calculate the threshold for each pixel. Then the next one is threshold type, So threshold type can be applied with this thresh binary. And block size, next parameter is block size. Here, the size of the neighborhood area used to calculate the threshold. So it must be an odd number. And the last one is C, a constant subtracted from the mean or weighted sum of the neighborhood value. And we visualize output in a graph. Here is adaptive thresholding and its inverse form. That's it for this tutorial. In this tutorial, we briefly learned how to perform thresholding with OpenCV in Python. The full source code is listed below. I'll put the link to this tutorial right below this video. You can access all the source code and information covered in this video. For more tutorials, please visit my website and subscribe my channel. Thank you for watching and see you next time.